tolerance, and in other way, it was told that there is a radial tolerance. So it's only one arrow.
Oh, okay, because I didn't understand the difference between total runout and actual runout.
Yeah. Uh, yes. Actually, the question is that what is the difference between total run out and just run out?
Yes, exactly.
Yeah. So the total run out means that you have a kind of a full cylinder, a 3D cylinder, 3D shape that you need to fulfill, and just to run out, it's a 2D case that you need to fulfill.
Okay.
And this time, this axial just means that when you rotate it, it can't move in an axial way. So it sets limit in this axial movement.
Okay. Can I show you my exercise? Because I think that right now I have is okay, but I'm not sure.
Yeah, yeah. Uh, Maybe we can do so that I will create the breakout room and you show
Yes, of course.
according to, but let's do it after a short while
Okay, perfect.
because I have something else that you should begin to do. If you don't have any questions related to this one, I'm not giving you time in during this lecture for creating these geometric tolerances for this guide role, but we are starting to do some next step. So this is something that you should do in your own time, to finish it in your own time. But of course, if you have any problems, I want to help you and give you instructions. So if you have any questions now, it's the correct time to ask them, and then I can create breakout rooms and we can talk about them.
Excuse me,
Yes.
I also have question about that because when we draw it in 2D sheet,
Yes.
they have the template where we can sign the name and other things. However, in 3D case, I just can't add the bill of materials, but not exactly what we have in 2D case.
Yes. I think this stage two, this doing all the things in a 3D format, it's not obligatory. It's an optional thing, and there might be some problems that you won't have all needed tools available in SolidWorks. So that was kind of, please concentrate on this stage one so that you will do only this 2D drawing. But if you have time and if you want to uh, find out these tools, then you can try to do it in this 3D as well.
So we just submit the 2D, not
2D.
3D.
Yes, yes, exactly.
Yes, thank you.
Because there is one add-in that you need to put in SolidWorks so that this 3D works perfectly. And I'm not fully aware that if that add-in is available in Virtual Desktop at the moment. I have asked that it should be there, but a couple of weeks ago it wasn't. So it might be that you are not able to do that stage two.
Actually, when I search on the YouTube, they have some kind of instruction to make the template in 3D, but I think it's quite complicated.
It's quite complicated, and of course, if you want to use your time, I think you will learn many things if you do that one. But I'm not accepting or demanding this from you.
Okay, thank you.
I was starting to open SolidWorks in virtual desktop at the moment because I wanted to check if the tools are available or not. But today I'm going to give you a new task, which is a little bit bigger, and we are going to use a couple of hours in our lecture. So it's something that we will start today, and we will continue it after your winter break. It's a design thing where you need to model something, and then you need to create these 2D drawings and put all needed uh, tolerance values and surface roughness values, and our aim is to create as perfect manufacturing drawings out of this topic as possible. I will soon tell you more about the thing, but at the moment I have this virtual desktop open and SolidWorks open, and I'm studying whether there is this add-in available. It seems that it is there. Okay, I will share the screen. I will quickly show you this. So at the moment I'm in virtual desktop, and I opened the SolidWorks, and there is this sheet SolidWorks add-ins, and it's here SolidWorks MBD. It's called model-based definition, and this MBD is the place for what you should use if you want to put some tolerances and such things into 3D model.
So we should use MBD for our assignments for this week, right?
This is optional. You don't need to do it, but if you want, you can play with this one. I can show very quickly how it works. I don't remember what were the dimensions for this roller, but let's imagine that it's something like this. So there is a place called MBD dimensions. And you can give here a size dimension, basic location dimension, a datum, and geometric tolerance. So at first, if I want to give some size dimension, for instance, for this hole here, I don't want that true information. I think there was some some values now. I don't remember what were the values, but in this way you are able to put this here. That's a very simple thing, but then you are able to also add a datum. And if I say that I want to put it here so that the datum is the center hole, or in real life the center axis here, it will automatically join into this dimensional information, so that if you still remember what I told you, that if this datum is in the same place where is this dimension information, then the meaning is the center axis of some element, not the element itself. And this is exactly what we want in this case. And then I would be able to put a geometric tolerance. For example, this total runout. So this is the normal runout, and this is the total runout. Then some tolerance value, and here a primary lane. So in this way you were able to put all the information in 3D model, and you would be able to create different templates, so and define it so that depending on what position you are looking this part, you either see or not see this information. And this has also some smart functions. Now you don't see any red color here because everything is told in a correct way. But for example, if I remove this datum, I see red color here. It says the total runout was 1. There is a warning, datum A has not been defined, even though it wants to see this datum A. So this has some functionality. And also, if I try to put this datum A in a wrong place, let's try how it works. If I put it here in this surface, instead of this correct place, I will try to put it on this flat surface. Yes, now it also shows red color and tells me that there is a problem, but it's not the same problem that the A doesn't exist. It exists, but it says that the tolerance feature spot runout is not coaxial with the datum axis. So it really knows what kind of basic datum this geometric tolerance needs. Okay, let's modify it, and okay, maybe it's easier to just delete this one and put it back on the correct place. And now I don't see anymore this red color. Yeah. So in that way, you would be able to put all needed dimensions and tolerances in the model.
Sorry, I have a question.
Yes.
Because as in the assignment, you say that the datum is in the axis of whole 10 diameter. So it's not the same as the hole itself. So I think we have to have an exit before we put the datum A.
Not necessarily, because the marking as it is now, it means the center axis because it's located exactly on the same place as the dimension. So in real life, it means the center axis. So there is not a difference if you put here, if we make this axis visible here, it would lead a similar outcome. But you are able to do it. It looks a little bit weird at the moment since it's not connected to this dimensional line, but you are able to do it, and this is also kind of correct.
Yeah, okay. No, thank you.
There's a question that there's a requirement about the surface. Can we add axis? Because like there's requirement to the two surface, two side surface.
Yeah, it means this side surface means this one and this one. These are the side surfaces that I mean, and you are able to do it, for example, like this. I think there was this flatness, and then there was this axial runout.
And do we need to add it into surface or?
Yes, you need to add it to two surface. So in a way like this. And
or is there any like function that we can add the center axis that we just add one surface and there's another surface that's symmetric to that, like in
yeah, I think it makes sense in this case so that you will just put this information in both sides. Now I'm once more. I try to show it how it is possible, but of course you could just do this kind of signs, but it is possible if you select this line here and press Ctrl and then drag with mouse. It kind of should be copied on another place, but it seems not to work at the moment.
Should it work like planes? When we copy planes, holding Control and moving them?
Yes. But it won't work at the moment for some reason. I will try this one.
So we cannot just add the center axis like into.
It's not a perfect solution.
Yes. Thank you. And in 2D we can add it, isn't it? Or we have to add into surface in 2D.
I still also in 2D I would kind of prefer to have it so that this information would be given into both surfaces.
Yes,
instead of this symmetric line. Okay, but now I don't want to use any more time for this, but because this was kind of an extra thing that you can do, but I want to introduce you this task that you should start doing now. And it's here, this sub-design and PDM. So maybe you remember from Technology in Practice course from last year, some group did have to disassemble this kind of rotary feeder. Do you still remember it? Any of you?
Yes, we are.
So now we are going to use this same part as an example, and your task is to design this kind of rotary feeder, not fully. I mean, I will give you all the casted parts, which are the frame and these both ends, but your task is to design a rotor here, which is the rotating part, based on the information what I give. So here you see the different parts that are inside this rotary feeder, the parts that it consists of, the frame in the middle, then a drive end and a free end. Then there are some sealing units in both sides. Then there is a gear motor on the other side, and a bearing on another side, and a rotation sensor, and of course a rotor here inside, which is rotating and doing the thing, conveying material. And mainly now your task is to design this rotor, and I will give the other standard parts, and we will check together how you will specify the correct gear motor. But the rotor needs to be designed so that it fits to all other stuff around. And you need to find the correct surface roughness values and correct tolerance values for the rotor surfaces that matters. And you need to all the time keep in mind the manufacturability. That's our aim number one in this story. So here you see it in a sectional view so that it is assembled. It's this blue part that you need to create, and all the other parts you will get. This gray parts I will give you, and now this gear motor, which is green in a section, this is something that you get from internet. And here are some dimensions, basic dimensions. And in a rotor, I can talk about blades, end blades, and shaft. So here you see what I mean with them. And there is some information. The diameter, as it's visible here, 250. Amount of blades, 8 pieces. Angle, 5 degrees. It means that the blade is not straight here, but it has a slight angle. Material thickness of the blade and end blade, 8 millimeters. The shaft thickness is something that you need to design because it's coming from other. Let's say that what kind of gear motor we need, that is specifying mainly that what kind of thickness for this shaft we need. Then it's told that the rotor rotating speed has to be 60 rounds per minute and the needed power is 1.5 kilowatts. And what you should do, you should create the 3D models and the assembly and all needed manufacturing drawings for this shaft, for this rotor fully, and also an assembly of the whole assembly drawing of the whole rotary feeder. And in a manufacturing point of view, you will need at least these kind of documents here. At first, it is told that you will need a DXF format drawings or DXF files from such parts that will be manufactured by laser cutting or by any other cutting. And in this case, it's this blade and end blade where you need these DXF files. They are cutted. Then this is manufactured in a way that first you will do for the shaft this very coarse machining, and then you weld all the blades and end blades into the place, and then finally you will do the final machining for the rotor so that it is already welded. So there is 3 different steps. First, a soft coarse crushing, coarse machining, so that it is just prepared for welding. Then a welding assembly, and then final machining of the rotor. And then, of course, the assembly drawing of the rotary feeder itself. Okay, and how you should start now today? I will give you now these parts, the standard parts that they will be available for you in PDM, and then you can start creating and modeling this router. And I will guide you. I will give some instructions how you should do that one. But at first, just a moment, I need to do some modifications inside our PDM. I will very soon tell you where to find this information. Okay. So which means the standard parts for rotary feeder. And there they are. If you just click, should be visible in the preview window. So there is a frame. Then there is an end plate. A sealing unit. And this is a bushing that comes together with the ceiling unit. And then a bearing. What you are missing is the gear motor, but that's something that we will later download from internet. And of course the rotor itself. But now you can start in a way, for example, so that you will open this frame in your own computer, in your own SolidWorks. If it asks that do you want to proceed with feature recognition, you can answer no, we don't need any features now. This is not a native, originally not a native SolidWorks file, so you see only imported here. And this is now a read-only file, and it has to be read-only because this is a standard part and you don't want to change it. You just need to use it as it is, and it can be read-only. It is very fine. Don't try to do anything for it. Instead, you have to create an assembly. So file, make assembly from part, and use this assembly lab format. And when you are creating assembly, it makes no sense to click on a mouse somewhere here, because then a first part is put in some random place. Instead, if you just press this OK, then the origin of the part and the origin of the assembly and all planes will be aligned in the same way. So this is always the best option when you create a new assembly. To first part, just press the button here. And now the origin of the assembly and the origin of the part are in the very same place. And also the planes, the front plane, top plane, right plane of the assembly are the same as in part, and it makes life more easy.
Sima, I guess I have a problem with PDM because the only folders I see are purchased parts, I guess, and tests, and I don't see any trade folders.
At all.
Yeah, I just have 2 folders there, and that's it.
It's same to me also.
Yeah, great. No, not great, but at least we know what's going on.
Okay. Let me check what is the situation. So this is a tool for administrate the PDM, and I have created a group for you, and there are some folder permissions. So you see this purchased components and you see the test folder. You should be able to see also this courses and machine design 2021.
Well, last time I used the school computer, I could see all the folders, but now from the virtual desktop, there are only like 2 folders seen at all.
Okay. Hmm. So how about now? If you update the view,
Same. No third folder for me. Don't know how about the rest of the guys.
so could you log out from PDM? Oh, okay. Close the PDM and open it again.
It appears in my folders.
I can access to the machine design to 2021 now. Yeah.
So now it works.
I can see the folder courses.
Yeah, what works for me, but now all the courses are green. I don't know if it's good or a bad thing.
So can you share the screen and show me how it looks in your side at the moment?
Can it take a couple of minutes because I'm using my phone for the connection.
How about someone else? Do you have a computer there so that you could share the screen so that I will see how it looks at your side?
Yeah, Timo, I had the same issue, but now it works for me. I have a folder with courses.
Okay. Okay, now if you go back to Simia PDM level, okay, courses, fine. Okay, and you see big list of different courses there. Machine Design 2021. Okay. What if you open some other course, for instance, this Connect Technical Overlooks, okay, and you are able to see everything inside.
Yeah.
Okay, I need to do some changes. But anyway, now you have access to this Machine Design 2021, which is a good thing. I just need to tune it a little bit.
Can I stop sharing now?
Yes, you can. And now find the frame that I showed you and open it to SolidWorks and create a new assembly. So now there is the assembly and to remind you how to operate with this PDM, you need to first give this necessary information with CustomWorks. So you need to give a new item number by pressing this Get New button and give a description. This is a rotary feeder assembly. And I will put my family name here. And for an assembly, I think this is everything what we need. And then it's very important to save the document by using this button, what you can find inside CustomWorks. So do not use this normal traditional save button when you save first time, but you need to use the Save Document As button inside CustomWorks. And then you have to go to the folder Saimia PDM and Courses and Machine Design 2021. And then you can create your own folder here. You can give your name and save finally the assembly here. But please remember that this is still not yet checked in, which means that if you now just close the SolidWorks and go away from virtual desktop and come after 1 hour back, there is nothing. It's empty. So there is this one step. You need to open this SolidWorks PDM tab and press this Check In button. It's not needed to do every time. You can do it, for example, every time when you stop working and then think that now it's a good time to upload all files into the PDM. But it's just very important to remember that if you are not doing this check-in, then you got nothing in your computer. Okay, now I want to check in the assembly. I'm not able to check in the part because I don't own the part. It's the read-only part. So this is the only document that I'm able to work with. And I want to keep it checked out so that I'm able to continue working with my assembly. That's the reason why I put this check mark on also in this box.
I'm sorry, I cannot check in with my assembly, even though I have saved it in the PDM.
Try to save it once more, not with this CustomWorks save, but press Ctrl S, for instance, and does it work or does it help?
But when I Ctrl S, do I have to still save it in the PDM?
I think it just saves it in the same place. If you press Ctrl S, it saves it in the same place that you already originally saved it, so it doesn't have any, you don't need to change anything.
Okay. I cannot.
Okay.
It said that it's warning that the name is not unique.
Okay. Could you share the screen for me?
Okay.
Okay. The problem is that you didn't give the unique name. It is only ASM1. So press Cancel. and you need to go to Custom Works and press this one button, this yellow part, what is in the left side. No, below, so that you can activate the part. The place where it reads SM1, no, it's inside Custom Works. Open Custom Works.
Yeah.
And activate the part. It's the yellow button, just a little bit left.
This.
Down, down, down. Now right a little bit. Right, down. That one. Okay. So you are not. Okay, now you could open the. Are you able to open the properties window for Custom Works? So you see these icons up there. Yes, that one. Okay, it seems that did you run the SolidWorks settings in the beginning, like I asked?
Where can I find
It's the same settings that we used in this. Well, that's it. SolidWorks and Custom Works settings.
I think I have downloaded.
Please don't. No. You need to close SolidWorks first.
Okay.
Simo, I did run the settings and I have same problems with Custom Works now.
Okay, let's see. Yes. And then open SolidWorks. These settings needs to be run every time you open this virtual desktop. They won't stay in a memory. Create a new document, a new assembly.
Oh,
Okay, now you see all the stuff.
okay.
And now you should fill the information which is inside Custom Works and then press the save button what is in Custom Works.
So now can I do it with my file? Like in this?
What was the other part? What was inside your?
Yeah, I just saved the frame.
But that was not supposed to be saved.
Oh, okay.
Wait a moment. Wait a moment. How were you able to save it? Because it was in a read-only stage.
I didn't remember. It just said you have unread only. Do you want to continue? So.
So you need to give a new number. Get new number. Press this button. Get new number. Don't type anything.
Okay.
And then in a description, give some. No. You can just type there that this is your rotary feeder assembly. And in a description too, you could put, for example, your name. and then press this apply button, and then press this save button. Yes, in that place. And now if you go to this PDM tab, what is below the customers, stay still in SolidWorks. Okay, press one time Control S. Yes, and now there is this check-in available.
Oh, okay. How about this part? I accidentally saved it.
Okay, so you gave it, okay, press cancel. Don't check in this as is it. Press cancel. No.
Oh.
Okay, so now there is a problem. If you gave a same name what already exists, and this causes problem. Because I told that you should not use the same name.
Okay, so now
Remove it. If that is something that you have created by yourself and manually given the name, then remove it. Okay, yes, this way. Okay.
can I also
Yes,
delete?
you can also remove that one. And then what you should do for the assembly, go to the SolidWorks now. And that is a wrong component now because you have a, you should use the original component and not create a new one. So from the assembly, remove this component fully. Sorry, I need to answer phone. Okay, so now you have an assembly and it is empty. And now you should add the component that you can find from PDM. And it's yes, that one. And now yeah, now these are all the problems that now occurs because there are now two components with the same name. that is forbidden in PDM.
Okay. So can I like delete all and restart from the beginning?
Maybe I don't know other way to do it. So close SolidWorks and delete everything from the CPDM folder. And
Okay.
I can manually go to recycle bin. Wait a moment. Okay, I don't see it at the moment. But start again.
Okay, I think now I know how to do it.
Yeah,
Yeah, thank you.
thank you. So, as you heard, it is very important that you don't give manually the same names for the components that already exist on the PDM. It causes only problems because the PDM operates with the help of the name of the component, and if there are two components exactly the same name, there is a failure. And that's why it's very important to use this button inside CustomWorks, which is get new number. And every time you create a new part that your target is to put inside the PDM, you should press this get new button so that you get a unique number. And like I told, I created an assembly, and in my assembly I still can use these original parts. As you can see, the name of this component is the one which was found under courses and machine design 2021 and sulkusyöttimen vakio-osat. It's this one. I can use this component. I don't need to create my own, but I will use some existing component here. And I also tracked here another component, which is this end plate. And actually I can make another one. So I will go to assemble, or I don't need to do it in that way. I can just open a folder, and this is an end plate, and I will just drag the component here because I want two pieces of them. And then I can do the assembly. How about the rest of you? Have you managed to do the same things?
I'm
Do,
trying to.
do you mean the assembly one or the PDM one?
To create this assembly and put something on a PDM.
I have some problem in assembly because like when I add the bearings into here, the screw are not at the same axis.
Do not put bearings yet. The only thing what you need to do now is to add these end plates and the frame. That's enough for now.
Oh yes.
Okay, now I have an assembly so that I have a frame and the end plates but no rotor inside. And I think the next step would be that I would need to start modeling the rotor. And in rotor, I will need 3 different parts. I need a shaft and then a end plate and a blade that will be put on a shaft. So I need to create a new part. And if I start by creating a shaft, and at the moment I don't know what are the reasonable values for the shaft. I just start by modeling and give more or less random values. For example, I start so that it's the diameter of the shaft, starting diameter would be 80 from the middle. And then I will say that it is 600 millimeters long. And in this very first step, I told you that there is needed this coarse machining, which means that I need to remove some material from both sides. For example, 5 millimeters in diameter. So that the shape will look like this. So this is the first step what you do. And I will do the same thing from the other side. And of course, I need to give these values inside CustomWorks. So a new number by pressing this button Get New, and this is shaft. Maybe as a description I can say cars machining, and the preform is round bar. Dimension type is round bar. And the material S355. And then apply. So that was the shaft. The very first, with not correct dimensions, I just created the basic shapes and I later modified the dimensions so that they are correct. And I will press this Save Document As button and I will save it in the PDM in this same folder, my own folder. So now it's there. And then I need to create a plate, meaning the end plate. And the shape is quite simple. The outer diameter needs to be little bit more than 250 because the 250 is the final diameter after machining, but we need to let or keep some material that we can then remove away in a machining. So I will put here 255 as an outer diameter. And then there is a hole in the middle. And this diameter is, now the shaft was 75. And I want this to be very easy to set on the place because it will be later welded and then machined so that the other diameter is suitable. So if it's 75, I will give here 77 so that there is 2 millimeter gap. And the thickness is 8. And for this one also and the preform is plate and dimension type also plate. The thickness was there and the width and length can be the diameter because this much material it kind of needs when it is manufactured. And the material S355 and apply and save in the same place. Please note that I didn't do the check-in yet for any of these new parts because I'm going to do it in one time. So now I have a shaft and an end plate, and now I'm going to create an assembly of the rotor, and the shaft can be a first part, so file, make assembly from part, and in the same way use this assembly lab format. And just press this begin assembly button, and then let's add some components, which are now the end plate, and they operate like this, that they will be put here, and they are located with the help of this shape. And same thing for the other one. Okay, now I have a starting point for the rotor. And in CustomWorks, once again, I need to give information, a new number and description, rotor, and I will give my family name here once again, since this is an assembly. The assembly, in assembly, you don't need to give any preform or material information, so this is all you need. Apply and say and now I go to the main assembly, and I will insert my sub-assembly here. And then locate it so that I think it needs to be so that this is kind of in a center. So I will use this one special made tool. It's here advanced mates and width, and I can select, for example, this surface and this surface, and then from the mating point of view, this surface and that surface, and then it will be automatically put in the middle. Okay. Well, I see that this definitely has very wrong dimensions in a many way, but like I told, this was a starting point. I just gave some random dimensions for this, or not all dimensions were random, but some of the dimensions were just randomly given for this rotor. But now, for at least for me, I like to work in this way, that I just give something and then start to change it so that it fits in a place. But of course, I understand that there are many different ways to work, and I don't say that this is not the best and only possible one, but for some other people might be that another way would make more sense. But I wanted to have it in this stage so that now I have the rotary feeder that has already some of the main parts that I need in this rotor. And now if I go to check in the whole system, it will automatically collect the rotor and the shaft and the end blade of the rotor. So I don't need to individually check in all the components, but I can open the main level of an assembly and then check in everything in one time. And these two are the components that are the standard ones, and I don't want to check in them, I just use them. But these are the one, these three, which are made by myself.
So we don't save nor check in the components we took from your PDM. Well, not your PDM, but the standard PDM, because they are already in the system.
Yes, exactly. And
Okay,
if you have a look at here, the list, they say here the workflow state for these two parts, it is approved.
oh,
So,
yeah. I saw this. It means that they are like ready.
yes, exactly.
So can you briefly show once again how do we add custom works for the assembly? Because now I want to add custom works for my assembly of the end plates and the frame, and I can only add it for individual components.
So if you have an assembly like I have here now, I think only this information is needed, or this is an obligatory information, because for an assembly you don't give any preform because it consists of many different parts, and also it can consist of many different materials, so it makes no sense to give any material information for an assembly. But of course you need to have this unique number and the sum name, what is the assembly what you have.
Okay, but I meant the like technical execution in a way that when I open the custom works, I click on the parts and then it has like the parts information, but so I don't need to click anything.
You just need to click this button.
Oh, right, okay. Thank you.
No problem.
One more question, if you allow. So, do we need to save the assembly on our like own side?
The assembly needs to be saved in the same way as the part, so that you press this button inside custom work, the save document as, and save it in your own folder that you created in PDM.
Okay, so we don't need to save it on the computers.
No.
Okay, great. Thank you again.
Okay, I think this is a good point to stop for today, but it would be very nice if you could reach the same level where I am at the moment, so that you have your own assembly, full main assembly, and then you have your own rotor as a sub-assembly. And if you have done the check-in correctly, I should be able to see your documents from here. So at the moment I see some folders. Okay, I see that Kang, for example, you have a rotor done in a correct way, and the parts and an assembly. Yes, this looks good. And Nikolai, so far I don't see anything from you, so it might be the case that you haven't pressed the check-in yet.
Yeah, I'm still in process of assembling the frame and
Okay.
the side plates because I had some problems, but hope to deliver it soon.
Okay. And also in Tran, you don't have anything here yet, but I think you also need to press this check-in when you are ready, because before doing that, it is, if you don't do the check-in, then you don't get the materials there next time. And there are the files created by myself. We will continue this thing after your break. We will have at least